uh, uh, in computer programming, recursion is actually a concept where a function calls itself. So actually the recursion is used alternatively, where we use iteration. So you can say it is an alternative to iteration. Iteration means loops. So wherever we use iteration, we can replace that iteration with recursion. But why recursion if the iteration is available? So recursion is considered more, recursion is near to human way of thinking. Sometimes by using recursion, we can solve the problem more easily and with more clarity, and it is easy to understand and easy to communicate in terms of programming. So now let's do some programming to understand the concept of recursion in detail. So here we write a function. This is a function, I said a function, and here I call this function inside it. So this is recursion. So if we call the function a from within the main function, the control will come here, then this function will call itself and it will keep calling itself infinitely. So there will be an infinite recursive call of this function that will never stop. So just like iteration, where we use some condition to break the loop, similarly in recursive calls we use a base condition to break the recursive calls. So here we can use some break condition, like I say. Usually for base condition we use some argument within the function, like so suppose here is an argument n, and here we say if n is equal to 0, then return. Although this function is a void, has void return type, so we will not return anything, but this return keyword is not returning anything. It is actually used to exit from a function, just like the break keyword is used to exit from a loop. Similarly, return keyword is used to exit from a function. So when this condition will be fulfilled, we will be no more calling this function again, because when this keyword will be executed, we will jump out of this function and this portion will not be called. So this is the base condition where our recursion will stop. So here we call this function again with the argument n. So this way again we will not have this condition ever true, because we will calling n again and again, and n will not be 0. So say we call the function with n is equal to 4, so here n will always remain 4 and we will never come to this block. So we can do a trick here. We call this function a with -1. So now first time we will call it with argument 4. 4 would come here, condition is false. Here 4 minus 1 3, so we will call this function again with argument of 3. 3 here, condition false. Here 3 minus 1 becomes 2, then 2 minus 1 become 1, then 1 minus 1 become 0, and when n is 0 then this condition is true, and here we return from the function and this code will be no more executed, and here is the stop condition of the recursive calls. So this is recursion. If we call it, we do not have any infinite recursive calls. So to let's execute, display something. Let's display the function, the value of n. So what would be the output in this case? Just a guess. Let's dry run this code before seeing the output. As you know, the functions are called using the concept of stack. The function calls are pushed into the stack and then popped up from the stacks. And you know, stack is actually LIFO, last in first out mechanism. So here's the stack. First of all, control will come into the main function. Main function will be called. Then this main function will in turn call function A4. And this will be pushed into the stack. And next we will come here, therefore will come 3 will be, so next 2, next 1, next 0, and for 0 we will return from this recursive calls. So all these functions will be pushed into the stack, and when we will start popping up, first of all this will be popped, then 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 this, and finally main function will be popped, and this line of code will be executed and we will come out of this main function. So this is the mechanism how the recursive calls work. So now let's see the output. The output would be, when we will come here with function a with argument of 4, this is false, and this will display the value of 4 and space, and next we will call again with value 3, so 3 will be displayed here, then 2, then 1, and 0 will not be displayed because when 0 comes here, this condition will become true and we will return from the recursive calls and we will no more come here. So this is the output. So now let's do a trick with this function. I copy paste this function here and make it B, and this is B, and instead of putting C out here, I cut it from here and place it under this function call. So now let's see what happens and let's see what is the output. I call function B. So here the recursive calls will be just like same as here, main function, then function 4, function 3, function 2, function 1, and function 0. But the difference is that when function 4 function B is again B, the difference is that first time when function B will be executed with argument 4, we will not be able to reach here, rather we will call the function B with argument 3, and then when we will come here with function 3, we will not reach here, rather we will stop here, and again we will call with argument 2 and then 1, and finally when 0 will come, then we will come here and this function, and we will return this function from here. So what will be the output? Here you need to understand the concept of recursion in terms of stack. We push the function into the stack this way and then we will pop it from here. So the functions are started this way but they are finished this way. So main will be started first of all, but it will be the last function to be finished, and this function was started at last but it would be the first function to be finished. So it finished here, and then we will see function B1 will be finished, and to finish function B we need to execute those lines which were not executed. It was not executed, we will execute it, so it will display 1, and then we will come here, and then function 2 will be finished. Here it was n was 2, so 2 will be displayed here, then 3, then 4, and finally this main will be finished and we will come here. So this is the recursion calls. So let me reiterate it again. We came here, we call this function b with argument 4, so we came here, then here, and we call it with function 3. So function 4 is not yet finished, it has to be finished, it has to print this value 4 here, but it is not yet finished, and we call this function 3. And function 3 is not yet finished, we called function 2, and function 2 was not yet finished, we called function 1, and function 1 was not yet finished, we call function 0, and then function b0 was finished, then function 1 was finished, and when function 1 was finished, then we displayed this 1, then for this display 2, then 3, and 4. So this is the main concept of recursion, and in the next lecture we will see some more programs to understand the concept more.